Okay, we're continuing with the notes for sections 4.5 and 4.6 in Algebra 2. And we're switching from the determinant of a 2 by 2 to a 3 by 3 matrix. And as you can tell from the formula that's printed here, it's much more complicated. Now, having said that, we're not going to do it this way. I do think there's an easier way to do it. So you're going to just scribble that out, and I'll show you how you do this. Okay, on a 3 by 3 matrix, when you're trying to find the determinant, you simply, well, I won't say simply, you replicate the first two columns. Let me highlight the first two columns. I'll do the first one in purple. And you put them right behind the original matrix. Let me get the next one here. I'll do it in green. We'll replicate that second column, and we'll put that right here. And so let me do that. We've got a first column that's -1, 2, and 0. And a second column that's 3, -4, and 1. Now, once you've replicated those columns, okay, you want to, I'm taking the highlighting off here. You want to start by setting up the next part of this. You want to set up two fairly long parentheses with a minus in between them. And so far, that is actually similar to what it looked like when I did the 2 by 2 determinants. Now, what you're going to do next is calculate each of the downhill diagonals, and you're going to put those answers in the first one. So this first diagonal here, if you multiply those three numbers together, you get -4. Then you switch to the next diagonal, and anytime a diagonal has 0 in it, you will end up with 0. If you think 3 times 6 times 0, you will get 0, so put +0 there. Sometimes I didn't even bother to do that. And 5 times 2 times 1 will finish this out, and that's going to give 10. Once you've done the downhill diagonals, then you switch directions and go in the uphill direction. So that pair is going to give 0. I'll go ahead and write in 0 after I set up my target down here. There's where I'm going to put these numbers. So we had 0 to start with. The next number will be what we get when we multiply those three together, and they give -6. And then the final uphill diagonal also gives -6. So now we boil these down. The first parenthesis has 6 in it, and the second one has -12. Double negative going on there. The determinant of this matrix is 18. Okay, let's do that once more. We're going to start with the downhill diagonals. Now we're going to start by replicating column 1. This is column 1. I'm making a copy of it. That's all that replicating means. And 2, -1. I'll try and do that a little more neatly. 3 is the second column. You don't replicate the third column. Okay, the first thing you do is set it up here. And the downhill diagonals are the lead. That's what you start with. So we're going to go these three numbers multiplied together. And if you multiply 4 times -1 times 6, you get -24. And we'll add to that this product, which is 10. And then we'll add to it this product, which is -18 when you multiply those three numbers. Okay, in the other direction, we multiply here, you get, let me change colors here just a second. Okay, when you go in this direction, you get -3. And the next one would be, let's see, that would be 60. And the final diagonal in this direction is -24. So in the first one here, we get -32. I better double check that here. Yeah, that's -32. And in the second diagonal, you get 33. And let's see if I'm right there. 60 minus 27 would be 33. Okay, so this one here is going to give negative 65. There's your determinant of that matrix. So if the matrix were matrix C, then we would have the determinant of C is negative 65. And if this one was matrix M, the first one I did was matrix M, then the determinant of M is 18. There's just two different notations for writing down determinant, and I'm trying to remind you of that. Okay, we'll pick up on page 3 in the next video.